Ever considered Earth as flat? A seemingly absurd idea, but a provocative one indeed. What if, contrary to our school-taught geography, our dwelling was a giant flat disk, majestically spinning in the limitless cosmos, with its inhabitants totally clueless about their real home's shape? It's a daring supposition that rattles the very core of our understanding. But what if it was true? Intrigued? Stay tuned as we plunge into this provocative exploration. The first thing to consider would be gravity. It's this ever-present yet invisible force that forms the basis of our understanding of our world. A constant energy that affects every single thing that exists on our planet, from the smallest grain of sand to the largest mountain. This unseen force, the one that keeps us grounded and connected to the world, operates on a principle as simple as it is profound. Mass attracts mass. Let's envision our Earth as a sphere, a perfect globe spinning in the infinite realm of space. Within this sphere, the mass is distributed evenly. This equal distribution of mass ensures the gravity can perform its function flawlessly, pulling everything toward the globe's center, keeping us firmly planted on the ground. It's a harmonious balance, a dance between mass and gravity that allows life as we know it. Now imagine a different scenario. A flat Earth, just as vast but fundamentally different in structure. In such a world, gravity would operate quite differently. It would pull everything towards center point, not down, as we are accustomed to. This alteration in the gravity's behavior would lead to an unusual phenomenon. The further you move from the center, the more you would feel like you're not walking on a flat surface but climbing a steep hill. This means the further you move from the center, the more you would feel like you're climbing a steep hill. Next, let's explore the concept of day and night. This is a captivating phenomenon that has intrigued mankind since the dawn of time. Firstly, let's consider our planet, Earth. It's not flat, as ancient civilizations used to believe, but a sphere. Spherical shape plays an integral role in our understanding of the day and night cycle. In essence, Earth's rotation is what generates the periods of light and darkness we know as day and night. As the Earth spins on its axis, it allows different parts of our world to be in sunlight while other parts are shrouded in darkness, giving us the alternating vistas of day and night. This rotation creates the beloved rhythm of life we know, the rising sun that signals a new day, and the setting that paves the way for the tranquil peace of night. Now let us consider a hypothetical scenario, a flat Earth. Here, assuming that the sun is still located at a distance, an interesting phenomenon would take place. If the Earth were flat, the entirety of the Earth would likely be illuminated at the same time. This means that it would be ceaselessly day everywhere, altering the familiar rhythm we are accustomed to. Alternatively, depending on the sun's position, it could be a never-ending night. This thought experiment tells us a lot about the importance of Earth's shape and its rotation. It's a testament to how these factors combined give us the wonderful and cyclical experience of day and night that we encounter daily. On a flat Earth, assuming the sun is still at a distance, the whole Earth would be lit up at once. It would be perpetually day everywhere or night, depending on the position of the sun. The seasons too would be drastically different. This change would fundamentally alter the rhythm of life as we know it. Currently, our planet Earth has a characteristic tilt on its axis, a fascinating slant that breathes life into seasons. This tilt is responsible for the beautiful transformation we witness every few months as Earth tirelessly orbits around the sun. This cyclic dance creates a mesmerizing pattern of warm summers, vibrant springs, charming autumns, and silent winters. Imagine a different scenario, a flat Earth devoid of this tilt. Picture a world that doesn't lean to and fro as it journeys around the sun, but rather stands still, unchanging, unyielding. In such a world, our familiar concept of seasons would cease to exist. There would be no blossoming of flowers in the spring or the fall of leaves in autumn. There would be no refreshing summer or a tranquil winter. It would be a world with a climate, unchanging and constant. This single change would have profound effects on all life forms. The rhythm of life would be thrown into disarray, with animals and plants struggling to adapt to the sudden monotony. The climate, being consistent year-round, would greatly impact the diversity of life in ecosystems. The myriad of life forms that are molded by the changing seasons would be lost, leading to an ecological imbalance that would be hard to fathom. The seasons, too, would be drastically different. What about circumnavigation? This concept is intriguing, isn't it? As we currently understand it, we attribute our ability to the globe due to the Earth's spherical shape. Interestingly, our sophisticated means of transport, like ships and airplanes, can embark on a journey in a straight path and after a certain period, arrive back at their original departure point. This is seamlessly possible as a result of Earth's unique and intriguing curvature. The logic behind this is simple, yet profound. Imagine a plane taking off from an airport and flying straight without deviating from its route. As it starts its journey, it rises above the city, gradually reaching higher altitudes. Over it sails across countries, oceans, and continents. It keeps flying, guided by the Earth's gentle curve. Eventually, the plane comes full circle and reaches its starting point. However, on a flat Earth, the scenario would be drastically different. Instead of a free-flowing round trip, it would be more akin to moving across an enormous plate. The North Pole, for instance, would be positioned in the center, with all directions radiating out from it. The further you move from the center, the colder it gets, until you reach the peripheral extremity, Antarctica. This icy continent would presumably be located around the edges, encircling the other continents like a boundary wall. Finally, consider the implications for space travel. This thought alone forces us to take a step back and truly analyze the consequences of such a drastic change. The curvature of our planet, often taken for granted, serves more than just a visual spectacle. It is essentially what makes space travel possible, providing the necessary gravitational pull required to slingshot spacecraft into orbit. Without it, the very mechanics we depend on for venturing into the cosmos would cease to exist. The dynamics of launching spacecraft, the calculations required for trajectory and speed, the chance to explore other celestial bodies, all these would be impacted profoundly. This would force us to rethink the way we approach space exploration. We would need to develop new technologies, new theories, and new ways of understanding the universe. The challenge would be enormous, potentially even insurmountable. Yet, it is through overcoming adversity that mankind has always progressed. Thus, the concept of a flat Earth not only questions our ability to conquer space, but also challenges our resilience and adaptability. With no curvature to slingshot spacecraft into orbit, the dynamics of space exploration would be entirely different, if not impossible, as we know it. To summarize, if Earth were flat, gravity would work differently, pulling everything towards the center. Day and night would occur simultaneously everywhere. There would be no seasons due to the lack of tilt. Travel would involve circumnavigating a disk, and space exploration as we know it might be unfeasible. While it's an intriguing thought experiment, the scientific evidence overwhelmingly supports a spherical Earth. It's a testament to the power of science and observation that humans were able to figure this out thousands of years ago. So, while the Earth isn't flat, exploring these what-ifs helps us appreciate the complex and beautiful mechanisms that make our planet what it is. Our exploration of the flat Earth hypothesis wouldn't be complete without a brief dive into its history. Ancient cultures, from the Egyptians to the Chinese, held various beliefs about the Earth's shape. While some did believe the Earth was flat, others proposed it was cylindrical, rectangular, or even round like a disk. Fast forward to modern times, and the flat Earth theory has seen a surprising resurgence, largely due to the internet and social media. These platforms have enabled the spread of misinformation, leading some to question the scientific consensus. Despite the overwhelming scientific evidence, flat Earth theories continue to persist in some corners of the internet. It's a fascinating testament to the power and persistence of belief, even in the face of reality. So, why do some people believe in a flat Earth despite overwhelming evidence to the contrary? Well, there are a few key factors at play. First, there's a deep-seated skepticism and distrust in authority, which can lead individuals to question widely accepted scientific facts. Second, the allure of conspiracy theories can be strong, providing a sense of intrigue and mystery that some find compelling. Lastly, humans have a tendency to seek patterns and explanations even when they're not there. This can lead to the creation and acceptance of alternative theories regardless of their validity. Understanding why people believe in flat Earth theories can give us insight into human psychology and the spread of misinformation. It's a fascinating study of belief, skepticism, and our innate desire to question the world around us. The spread of flat Earth theories underscores the paramount importance of scientific literacy. Education plays a vital role in fostering an understanding of the natural world and combating misinformation. Scientific illiteracy, on the other hand, can lead to the acceptance and perpetuation of unfounded theories, making us more susceptible to misinformation. Critical thinking and skepticism are essential tools in evaluating information and discerning fact from fiction. Thus, promoting scientific literacy is not just beneficial but crucial in combating the spread of misinformation and ensuring a well-informed public. The world may not be flat, but it certainly is complex, and understanding it requires a keen and educated mind.